Yo. Um, so anyway, check this out. We're supposed to be doing completing the square part 3 today, but I don't feel like it. So I say we practice our TikTok renegade dance. What do you think? Now look, no one can tell Dr. Shoemaker. All right. So yeah, we're gonna learn how to do this. Okay. I've been practicing. Okay. I guess I gotta start over here. Hold on. Come on. Seriously, you thought I was going to do that? April Fools. Couldn't be with you today, so I thought I'd get you next week in my video. Funny, huh? I'm sure you're upset. But anyway, we got to do completing the square part 3 today. Now, with part 3, the difference is going to be that now our A term is going to have a number in front of it other than 1. So this creates a small problem, but it's an easy fix. So we're going to do some of these. We'll start easy, work a little more difficult. I have one example for you to try it at the end. You know the drill. If we need more videos, we will do them. If you do not have your calculator handy, I got mine, or have one, you can, of course, go to Desmos. So if you want to pause the video right now and pull up Desmos Scientific Calculator, you can use that as well. I know you probably have to tile back and forth between the screens, but you can always pause this and do this. Let's find a marker that works. How's that sound? So we'll go with purple. I wonder why that black one died. Gone. So we've got 4x squared minus 8x plus 36 equals 0. Now, like I said, some are going to be easy fixes, some are going to be a little bit uglier. Now, this creates a small problem, and that small problem is that it's harder, I mean, a lot harder to create that perfect square factorization when you have a coefficient in front of the x squared that's not 1. So, we got to get rid of that. Now, the beautiful thing is this. We can get rid of that and go back to having a coefficient of 1 if we simply divide out by whatever that a term is. So whenever we have an a that is not 1, in other words, there's a number in front of the x squared, we've got to get rid of it first. So that's what we're going to start with. We're going to start by dividing this whole thing by 4. Now, technically, we have to divide both sides because it is an equation. Of course, dividing by 0 doesn't do anything, still stays 0, but that's technically still mathematically what we're doing. So when I divide out by 4 here, I'm left with x squared minus 2x plus 9 equals 0. So one simple step, we're back to a problem like we just did prior to this. So let's do this one quick, should be pretty easy. So obviously this guy's not going to factor, no way to get a 9 and get a negative 2 in the middle, so we're going to have to do completing the square. So once again, we need a new c value. So we get rid of that guy by taking him to the other side. New c value comes from doing that little b over 2 squared. That's the only time I'm going to write that. I'm pretty sure we should know that by now. We're on our 3rd video. So we're looking at negative 2 over 2 squared. Negative 2 over 2, of course, is negative 1. And squared, of course, is 1. There's our little cheater. So that means that we will be adding 1 to both sides. So, looks to me, this guy's now going to factor as a perfect square. Negative 9 and 1 is negative 8. So this guy factors, if you can't tell from here, you can use your little cheater over there. He's going to factor as x minus 1 quantity squared. So at this point, we're going to solve with our roots. We're square rooting. We're not forgetting our positive and negative. Of course, square root of x minus 1 quantity squared is just x minus 1. Over here, well, 2 things are going to happen this time. We're going to have to poke our eye out, and we can reduce that radical. Of course, if you poke your eye out on your own, put this into your calculator, it will reduce it for you. We should be able to handle that. That's pretty easy. 8, well, I'm going to poke my eye out. 8 is 4 times 2, so I can pull a 2 out, leave a root behind. So I'm looking at plus or minus I2 root 2. We will write that as 2I root 2. when we're done here. So we're going to go ahead and add 1 to both sides. And we're looking at x equals 1 plus or minus. I'm going to clean that up as 2I root 2. So there it is. We can leave it like that. Keep in mind that is 2 different solutions. That is not a whole lot different from what we did yesterday. Or I'm sorry, I guess it would have been 2 days ago. I'm forgetting because I'm doing all this a week ahead of time. Sorry. So yeah, anyway, that's the only new step that we really did today. Don't forget that when you're down here, poke your eye out, and don't forget that you can reduce radicals when they do have a perfect square factor. Hopefully that was okay. Let's move on and try another one. I have a feeling most of you are sitting here thinking a little bit, if we're going to be dividing, is there a time when things won't work out nice and pretty? Yeah, that's going to be the problem. Process is the same. You're just going to wind up with some uglier numbers. So let's throw one of those at you. We're looking at 2a squared minus 5a plus 12 equals 0. Okay, so right off the bat, and again, you could try your whole factorization, but I think we can take a look at this and go, that's going to be tough to make that happen. Okay, so what we're going to do is we're going to say, all right, we need a way around that. It's not factorable, so completing the square is our way. So in order to complete the square, I need that coefficient of a to be 1. So to make that happen, I'm going to divide both sides by 2. Yes, I know dividing by 2 or dividing 0 by 2 does nothing, but of course we're still going to show it. Dividing by 2 here, I'm looking at a squared minus 5 over 2a plus 6 equals 0. So yeah, you probably can see that there's going to be a little ugliness coming ahead, but our calculators will help us out with that. So completing the square is all about finding a new c value that makes this factor as a perfect square. So first thing I'm going to do is I'm going to take that c value over. And I'm going to go ahead and say, well, I need to come up with a new c value. Now that new c value is b over 2 squared. It's the same process here. I'm going to go ahead and put the b over 2 squared there. Now, problem here is now you're dealing with 5/2 over 2 squared. Well, that's no big deal. Oops, forgot my negative. Sorry about that. So it's no big deal. 5/2 divided by 2 just becomes negative 5/4. The nice thing is the factorization will be easy because we have our little cheater here. So squaring negative 5/4, of course, negative becomes positive, and 5/4 times 5/4 is 25/16. So looks like I'm going to be adding 25/16 to both sides. Adding 25/16. Sorry, that's all jammed together. My board is only so big down here. So this is going to lead to a couple things. One, I'm looking at a factorization here. This should be a perfect square. I know it's ugly. Hey, that's a fraction. I'm scared. No, you're not. You know what it factors into. That tells you what it factors into. So this is a minus 5/4 quantity squared. And that's going to equal, well, that ugliness taken care of in here. I'm going to go ahead and do negative 6 plus 25/16. I don't know if you can see that. I get negative 71/16. Now here's the good news. If you're dealing with a not so ugly number there, since this guy had a fraction of 16 that came from squaring a number, this guy's going to have a fraction of 16. So when we square root, it's going to pretty up a little bit, so don't be worried about that. So now at this point, we solve with roots. Same process. I'm going to square root both sides. I'm going to square root both sides. So square root of a minus 5/4, quantity squared, is a minus 5/4. Root and the square undo each other. Now over here, we've dealt with these. This is why we had that pre-skill to work with things like that. So when we ran into this, we had the skills to deal with it. So here's the first thing. I'm going to take a look at that. I'm going to realize a couple things. One, an I is going to come out. Two, if I break this down into the square root of 71 over the square root of 16, I can make it a little bit more manageable. First off, I know the I is coming out. Second of all, I know the square root of 16 is 4, so that's pretty easy. Now, square root of 71, we can punch this into your calculator if you have one. You can also search what goes into that. Fortunately, there's no perfect square factors of 71, so that guy's going to just stay underneath. So right now, that's what I'm looking at. Looks ugly, but with the work we did before, that should be fairly manageable. So at this point, we're going to go ahead and add that 5/4 to both sides. Add the 5/4. Now, ooh, I forgot my positive and negative. Positive, negative, positive, and negative. So at this point, I'm going to have A equals. Now, you can't combine this 5/4 with that guy. This guy doesn't have an I, he does. So what we're going to do is we're going to look at that and say, okay, well, that's 5/4 plus or minus I root 71 over 4. Now, that's ugly in itself. We can clean that up a little bit because they're both over 4. So I'm going to jump over here. I can write that as A equals 5 plus or minus I root 71 over 4. Non-real and as ugly as they get. Okay? Let's recap a little bit. Just said mainly because I forgot my positive and negative there. Sorry about that. So we started with a trinomial, had a coefficient larger than 1. So we divided it out by that. We got this now with a coefficient of 1. We now can apply it. Only difference is now we have a fraction. So we do our b over 2. Negative 5 over 2 divided by 2 is negative 5 over 4. That's going to tell me what my factorization is. When I square that, no big deal. It becomes positive. It's 25/16. That's what got added into both sides, my new C value. Then I know my factorization because of that cheater. I added that in my calculator. When I square root to solve, don't forget your positive and negative like I did. Put your positive and negative in, square root. Then I'm dealing with that negative 71 over 16. So, two things. One, I pokes out. Two, I can split this into root 71 over root 16. Root 16 is 4. Root 71 didn't reduce. It stayed put. Last step is to add that 5/4. That comes over. That's ugly. They're both over 4. Might as well make it one big happy fraction. Fun, huh? The nice thing is it looks a lot uglier than it really is because we've been going step by step. So it's impressive math, even though it's not that difficult to do. All right, let's do another one. Let's do 4k squared minus 5k minus 50. And that's going to equal 0. Okay, so here we go. Again, ugly one. Actually, you could probably rack your brain here for a while, decide if it factors. But yeah, I'm going to just not deal with that. I'm going to go ahead and say, I don't want to sit here for 5 minutes, try to make this factor and find out it doesn't work. I could have been doing completing the square the whole time. So let's just do that. To complete the square here, first thing that I got to do, get rid of that coefficient of 4. So I'm going to divide everything through by 4. I'm going to try to write a little bit smaller. I hope you guys can see that just so I have room. So dividing out by 4, I'm looking at k squared minus 5/4 k, and then minus 50/4, which would be 25 halves when I reduced. Easier to stick with this. That's going to equal 0 over 4 is just 0. Now, that's ugly, right? Well, here's what we're going to do. We're going to go ahead and say we need a new C value. We want to make this factor as a perfect square. So first thing I'm going to do is get rid of that 25 halves. So this becomes k squared minus 5/4 k. If I add 25 halves to both sides, it just becomes 25 halves over there with that 0. So what am I going to add? Well, it's where I do my b over 2 squared. B is 5/4. It's being divided by 2, and that needs to be squared. Well, negative 5/4 over 2 becomes negative 5/8. I should probably show you that these calculators will handle that if I do negative 5/4 over 2. So if you see, hopefully I can show you that. See, it'll handle that. It'll do that for you. So before I square this guy, that's my little cheater. That tells me odd factors. When I square that, obviously becomes positive. I'm dealing with 25/16. So what I'm going to be doing is adding a new C value. That's what we just found. We're adding 25/16 to both sides. Adding 25/16. Okay. So two things are going to happen here. One, I can now factor this. I know that the perfect square factorization is k minus that 5/8 squared. And that's going to equal 25/2 plus 25/16. Might as well make use of our calculator here. Plus 25/16. I'm looking at 225/16. Okay. Now, at this point, I'm going to go ahead and solve this with perfect squares. So I'm going to square root, and I'm going to square root. I will not forget my positive or negative this time. When I do that, square root of k minus 5/8 squared is k minus 5/8. Now, over here, hopefully a lot of you guys are seeing something. The nice thing about this is, let me show you this too. I need to show you all these things your calculator can do if you have one. I believe Desmos will handle it as well. If you punch that in there, guess what? It works out. They're both perfect squares. The square root of 225 is 15. The square root of 16 is 4. So this becomes plus or minus 15/4. Simple enough. Then I'm going to go ahead and I'm going to add 5/8 to both sides. I'm going to add 5/8. Add 5/8. Now, here's the deal. That becomes k equals 5/8 plus or minus 15/4. So you're going to go ahead, since they're both real numbers, you're going to go ahead, punch those into your calculator, and figure those out. We're looking at 5/8 plus 15/4. Should have just done those in our head. That's 35/8. And 5/8 minus 15/4. We're looking at negative 25/8. So that guy actually worked out to be nice and real. He actually could have been factored, but the problem with that is that would have taken us a long time to sit down and figure that out. So that's what we wind up with. K equals that or that. We could also put that in a solution set and provide our answer. So I'm going to hope that's enough examples. I'm going to give you one up here. I'm going to have you guys pause and try. If there's any problems, I will make another video. You know that. We're going to make sure we're all good with this. The process is the same. It's just that the numbers are super ugly. That's all. Use your calculator. Use Desmos if you have to. Everything, is manageable with the right technology. So 3b squared plus 2b plus 5 equals 0. You know the drill. All right, guys, I went ahead and I worked the problem to this point. I figured we'll walk you through the rest of it. So if you want, you can pause the video right now, check out and see if you agree. If you do, awesome. And then you can go to that point. But let's take a look at what I did. First thing I did, divided by 3, get rid of that coefficient of b squared. That gives me b squared plus 2/3 b plus 5/3 equals 0. Again, point of completing the square. New c value that makes this factors a perfect square. So we take the c over to the side, it becomes negative 5/3. We find our new c value by doing b over 2 squared. B was 2/3. 2/3 over 2 is 1/3. Check it in your calculator or Desmos if you have to. So 1/3 squared is 1/9. That's my new C value that I'm adding. Now I know the factorization is b plus 1/3 because of that cheater. And I also know that negative 5/3 plus 1/9 is negative 14/9. So let's pick it up there. So at this point, to solve, I'm going to square root both sides. Square root. Don't forget your positive and negative like I did. So the square root of b plus 1/3 squared is simply b plus 1/3. That's going to equal. Now, over here, this is why I want to do this step by step. We do have our plus or minus stays put. Now, what's going to happen? Several things. One, it's a negative underneath that root. That means I need to poke my eye out. I'm going to split it into the square root of 14 over the square root of 9. And I'm going to go ahead and say, well, the square root of 9 is 3. I know that. So notice I'm doing it kind of piecemeal and slowly. Square root of 14, well, that's not a perfect square, and there are no perfect square factors of 14. If you have a TI-30 at home, you can check it in there, but the only factors of 14, besides 14 and 1, are 2 and 7. Nothing's a perfect square. So he's staying underneath there as the square root of 14. So last thing to do would be to subtract 1/3 from both sides, subtract 1/3. That cannot be combined with that non-real number. So I'm going to come over here. My final answer, since they're both over 3, I'll put the whole thing over 3. I'm looking at negative 1 plus or minus I root 14. There's my answer. Now, I know that wasn't a ton of examples. You can always go back and watch the examples over again. It would just be more of the same, and it's just the ugliness that comes with it. I will put another video up if we need it. At this point, you should be able to do your entire CUDA worksheet on completing the square. So do that. If you have questions, tell me what the numbers are. We can set up a Google Hangout, any of that stuff. Don't get worried about it. I apologize for the April Fool's prank, but I had to, you know. Hey, you guys have a good one. I'll see you soon.